Hello and welcome to another session where we are talking about statistics, we are talking about correlation, and we are doing an example sort of by hand, not statistical software, but we have already done our discussion. In a previous video, we have already done an example by hand with a hand calculator. Now we are essentially doing another example like that, but instead of using a hand calculator, I'm going to demonstrate how we can use a spreadsheet, specifically here, Microsoft Excel, and we can use that in a basic way as a glorified calculator because it has the benefit that we can lay out all our information in a much more convenient and effective way. Let me just delete that. That shouldn't be there. That's part of our answer. So we are going to demonstrate that, and we are going to look at an example from a book here. Let me just zoom in so you can see the title here. We're going to take an example from this book, Statistics for Psychology. This might not be your prescribed book. That's totally fine. Just the one I have available for this video. So we're going to look at page 485, number 14, 485, number 4. And we're looking for number 14 here. There we go. Let's make it a little bigger. Oop, maybe that's too big. No, that's fine. All right. So we are actually here looking for instructions of page 11, but the setup we can read first. 5 college students were asked about how important a goal it is to them to have a family, and about how important a goal it is for them to be highly successful in their work. Each variable was measured on a scale from 0 to 10, like that. Now I've already put those numbers in here. Let's just read what the instructions is that is referred to in 11 here. So we want to make a scatter diagram first. Then we want to see, do we observe any seeming correlation in that? Just our impression. And then we want to calculate the correlation coefficient and see if it is statistically significant. So first of all, let's make a diagram of these points, family to work. And another convenient thing about using a spreadsheet is the graphing. And the visual representation of this is so much more convenient. So we're going to go to, let's go here. I can pin this drop down over here with all the options. There's different tabs here at the top. We're going to go to, where is my insert? There we go. I want to insert a graph or a chart. Many different ways to do that. We're going to go for a scatter plot. And we're just going to pick the points here. That's a pretty good size already. I like to start with an empty one. So this is just the space. And now we're going to right click on this. And then I'm going to select the data that I want to represent. And here, I don't really like to use that top one. I'll just put in the 2 data sets by adding here. You can give it a name. I don't really care for this example. My X values, I'll select here the family values. And then the Y values, I delete what is in there. I know this is very small, unfortunately. I can make it bigger. And I'm going to select the work as the Y values. Click OK. Click OK. And there are my data points. Super convenient. I can give it a title and so on if I want to. So do we observe anything here? It's difficult to observe. Maybe there is this negative correlation here, and that one is an outlier. Maybe it's actually over here. It's very hard to say in this case. I don't have a lot of data points to really suggest probably here, but that's the whole point of calculating a correlation coefficient, because I can't just feel my way through this. So that is the next step, where we want to calculate our value for R, the correlation coefficient for this data set. So I have to calculate the mean of these two first, because as you know, we need to calculate the z-scores for each one and then multiply them. So z-score will rely on my standard deviation. So we have to get there first. First of all, the mean. We have some built-in functions that makes it a little bit more convenient than adding them together, divide by how many there are. We want to take an average, so I start typing, and I'm looking for the average function. Select them all, and Excel will automatically add them up, divide by how many there are. But let's suppose I don't know how to do that. We can go up here and insert a function, and then we can search. I want to calculate an average, so I search for average. And there's a description here that's hopefully big enough for you to see that it returns the arithmetic mean, which is exactly what I want. So I don't have to memorize these names as long as I have something I can search with. And then what is my selection? Selection's over there, the Y values in this case. Click OK, and you see it did the exact same thing. Now we want to calculate the square deviations on the way to the variance. So I'm going to start with an equal sign because I want to do a calculation. I want to do the deviation, so the x value minus the mean. Close my bracket to the power of 2. Click on enter. Press enter. And you see here that I can double click to check it. It's referencing the cell next to it as the x value and the cell over there, the pink one, for the mean. If I hover over the bottom right, I can drag it down and copy it to the next one. But you see that it did reference the correct x value, but the mean shifted as well, and now it's nonsense. I'll escape out of that. Let's go edit the first one and put my cursor inside the pink one, which shouldn't move as I copy the formula down. So I'm going to press F4 and it puts those dollar signs in there automatically, telling Excel that if I copy it, this position should always stay fixed. So if I copy it now, I see that, okay, the blue one did move with me. The pink stayed fixed as I want, because it should always take that mean. Then I'm going to copy it all the way down for all of those. Maybe check a random one and you see, okay, it's using the right numbers as it should. We can do the same calculation for the square deviation. For the Y values, you can totally type it in again, or I can copy this, which is essentially going to be the same formula, just put over here. Paste that, and you see that, okay, the blue did move right, but the pink is now referring to the mean of the x value. So I can just drag that over. It is still fixed. And now it's going to be the correct formula that I can hover bottom right corner, drag it down to copy the formula, check a random one, and you see, yeah, okay, it's referencing the correct things. The right blue cell is moving. The pink one is correctly staying put. Okay, so those are my square deviations for both. Then the variance here of this data set. Remember, you divide for these. This is the population. I divide by n, so it's the sum. Search for not dumb sum of all these square deviations. Close the bracket. Divide by how many there are, which is 5. Enter. I can copy this formula instead of typing it again from scratch. Right click, paste. and double check it. Always double check. And you see that the square deviations were added, dividing by 5. Perfect. Now we can calculate the standard deviation as simply the square root. Let's suppose, just for the sake of this illustration, let's suppose that I didn't know what the function name is for square root. I can just go and search for square root. And there's a bunch of options. That one returns the square root of a number. Perfect. Which number? I want to take the square root of that number. Okay. And you see sqrt was the function name that maybe now after a while I tend to remember it. I can type an equal sign, sqrt, right, that one. Tab to sort of autocomplete, and then just close your bracket. So after a while you remember the familiar, the ones that you use all the time, you tend to remember. So now I have my square deviations for both, and I can calculate my z-scores for each of these values. For the x value, that's going to be the deviation, which I'll do again. X minus the mean, which I'll fix with F4. Close the bracket, divide by the standard deviation, which I will also fix with F4, because I know I'm going to copy and I don't want those to move. Only the x value should move. Hover over the bottom right, drag it down, check a random one, and yes, it is referencing the correct cells. We'll copy that over to the y column. Double check it. Yes, of course, the mean should be the appropriate one. The standard deviation should be that appropriate one. They are both fixed. That one is not, so that moves. Beautiful. Press enter. Then I'm going to copy that down. Check a random one. Yeah, that seems to be good. Now I want to calculate the product of the corresponding z-scores. So it's that one times that one. Not fixed because I want them to be copied down. Check a random one. Perfect. And finally, the R, the correlation coefficient, is going to be the sum of those guys divided by n, or that's just an arithmetic mean. So that's the same as the average of them. And there we go. And as I maybe suspected, maybe this negative correlation was what was happening. This might have been an outlier. Who knows? Now I see, yeah, mathematically, without my bias view that I could potentially bring into this, this suggests a negative correlation. However, my sample could just be some rare sample of family and work ratings provided by these 5 people, and there might actually be no true correlation between these two in the population of all the people. So I want to set up a hypothesis test. Under the null hypothesis, I'll assume that there is no correlation. Is this correlation coefficient that I got strong enough evidence to suggest that no, there is actually a negative correlation? Because depending on the people that I interviewed, my correlation coefficient will be slightly different. This is just one of them. And we want to test that. This is R is equal to 0 versus not, so it's two-tailed at alpha of 0.05. My degrees of freedom for the t-distribution here will be n-2, so 3. Let's calculate a cutoff value. So if you remember, let's visualize it first, perhaps. Let's visualize it first. Let's see if this works over here. Let's draw with blue. That could have been straighter. Do I have a line tool here? Yes. Let's not trust my ability to draw very straight lines. Now I want to go to the pen. Just this one, blue. It's sort of like a bell curve, right? With a little fatter tail, somewhat symmetric. So let's visualize this. Two-tailed will mean that my cutoff sits on both sides, so that the area in the tail here is alpha divided by 2. So in our case, 0.025, 2.5% on each side, alpha divided by 2. So my T cutoff will sit over here and over there. So let's, oopsie, I need to go back to my cursor, like so. Yeah. Let's calculate that. Now you could use your textbook and look it up in a table, but another benefit here is that all those tables for the distributions are already built in. So let's go look at a function, insert a function here, and let's search for T distribution. There's a whole bunch of distributions here. Looking down the list for T. T, where are you? Now the T distribution is going to take an X value and return a cumulative distribution. That's not what we want. We have the probability here. We want to return the so-called X value in the distribution, right? The horizontal, in this case, T value. And what I like to do is, yes, there is a two-tailed one. I like to just put this manually in because I'm uptight. But there is the option to do it with a right-tailed and then just put in the alpha and it'll divide it for me. I prefer not to, just to be sure. So I want the probability of alpha divided by 2, or that's what I have in a tail. The degrees of freedom is 3, and it returns the negative 3. Let's write that in. Negative 3.18-ish. Okay. Negative 3.18, and so the other one will be 3.18. I didn't need to really bother with the two-tailed, though you are more than welcome to. Go back to my cursor here. There we go. So now I need to calculate my observed t-score. Where does this sit? Is it far enough away from 0 to suggest that, no, this distribution is not centered at 0? It suggests that the distribution is centered a little bit further away, and the true population parameter is not 0. There is actually a correlation. So let's see, how do we calculate that? Well, this formula is somewhere in all the books. In this case, in the book I have available to display, it's on page 459. Now I drew on the screen here, so just look past that. So it's over there. So take a mental image of that or write it down. I'm going to move it to the side so I can put in my formula according to it. It's going to be the correlation coefficient, which sits over here for us, divided by the square root of a whole bunch of stuff. So what you could do is you can close the bracket to make sure all your brackets are good, then go inside of it. Then I have to add another bracket divided by another bracket. So I have 1 minus the correlation coefficient squared over n minus 2. I'll just emphasize here, 5 is my n. It's really just the degrees of freedom, which I have there, but I already made the brackets. It's okay. Like so, press enter. And I have my observed t-score of negative 0.85, not 85, 87. Not that that 7 really matters because I'm far away from the cutoff. Let's make it red. So I'm way over here somewhere. Negative 0.87. So that shows that even though I thought this correlation coefficient was substantial, it shows that in the grand scheme of all the correlation coefficients I could have gotten, it's really not very extreme. And even in the case of the null hypothesis being true, meaning the true population correlation coefficient is 0, I could very easily have gotten this. So the evidence is not strong enough to suggest that the correlation is anything other than 0. So let's write that down. I can write that in a variety of ways. First of all, we'll say we do not reject the null hypothesis. But that's sort of a statistics way of saying things. If someone has this question and this problem of trying to see if there is some relationship between family and work priority, they don't know how to do it necessarily. They just want their conclusion in plain English. So we can refer to the question to double check our wording. That was on page 485. This diagram is annoying me now. Let's get rid of it. 485, number 14. So I might want to read that multiple times, right? To remind myself, okay, it's the importance of a family goal versus a work goal if there is a connection between them, a correlation. So I can say my conclusion in a more wordy way relating to the words of the original question and say the evidence is not strong enough to suggest that there is a correlation between, let's say, family and work priority. Based on this evidence, I cannot make any sound conclusion because the correlation could be 0, and just because of natural variations in the people that I select, I could easily get this correlation coefficient. All right, so that wraps up our example. Hopefully that helped you see another example we're sort of doing by hand, just with the convenience of a fancier calculator. Not statistical software, but just the convenience of a spreadsheet to organize my information, to see the formulas, and to have a little bit of help and avoid the tedium of doing everything over and over and over the same way. I can copy and paste formulas, so it's super handy. All right, we will wrap it up there, and we will see you hopefully in the next one. We'll just end with a little video explaining what we're all about, and then that will be the end. Until next time.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.